Denudational processes. The natural forces that shape and lower Earth's surface through weathering, erosion, and transportation. What is denudation? Etymology and definition. Denudation originates from the Greek term signifying, quote, reduction, encapsulating the natural process of lowering or sculpturing the Earth's surface. Planetary reshaping. These geological processes continuously reshape our planet, fundamentally contributing to the formation of the diverse landscapes we observe today. The 5 key processes: weathering, breakdown of rock materials in place; erosion, removal of weathered materials; transportation, movement of eroded materials; mass movement, gravity-driven material displacement; deposition, settling of transported materials. Weathering, the foundation of all denudational processes. Definition: the in situ breakdown of rocks and minerals at or near the Earth's surface. Types: primarily classified into mechanical, physical, and chemical weathering, with biological weathering often considered a subtype of both. Significance: prepares material for erosion, transportation, and subsequent deposition, contributing to landform evolution and soil formation. Understanding weathering. Weathering is the decay or decomposition of rock materials in situ, meaning right where they are, without any movement. Physical weathering. The mechanical breakdown of rocks into smaller fragments without changing their chemical composition. Chemical weathering. The decomposition of rocks through chemical reactions, altering their mineral composition. Biological weathering. The breakdown of rocks caused by the actions of living organisms, such as plants, animals, and microbes. Erosion, the next step. What is erosion? The removal of weathered materials through detachment of debris and clastic materials from their original location. Transportation agents. Running water. Rivers and streams carry sediments downstream. Wind moves particles across vast distances. Ice. Glaciers transport massive amounts of debris. Waves. Ocean currents move coastal materials. Gravity pulls materials downward along slopes. Deposition, the final stage. Process description. When transportation agents lose energy, they drop their sediment load, creating new landforms and deposits. Important clarification. Deposition is technically not a denudational process, rather it belongs to gradation rather than degradation. Key concepts. Understanding the fundamental terms in weathering processes. In situ, on the spot. In situ means weathering happens exactly where the rock is located. No movement involved. This distinguishes weathering from erosion, which requires material to be moved away from its original position. Disintegration process. Parent rock. Original solid rock formation. Detachment. Materials split away from parent body. Debris formation. Plastic materials created. Expansion and contraction. A powerful physical weathering process driven by temperature changes. Day cycle. Daytime heating causes rock expansion. Night cycle. Nighttime cooling causes contraction. This process is most common in hot desert landscapes, where extreme temperature variations create repeated stress on rock surfaces. Chemical weathering. Oxidation. Ion transformation. Atmospheric oxygen converts iron from ferrous to Fe² to ferric Fe³ state. Visible results. Creates reddish surfaces on materials, like rusting of metals. Carbonation and water processes. Chemical reactions facilitated by water action that break down rock materials. Carbonation. Carbon dioxide in water creates weak acids. Solution. Minerals dissolve in water. Hydrolysis. Water molecules break chemical bonds. Debris. The end product. Weathered materials that come in various shapes and sizes, also called regolith. Clastic materials. Weathered fragments. Material sources. Weathered materials are categorized based on their primary origin within geological and biological systems. Igneous origin. Derived from the breakdown of rocks formed by the cooling and solidification of molten magma or lava, such as granite and basalt. Sedimentary origin. Composed of fragments from pre-existing rocks, organic remains, or chemical precipitates, later compacted and cemented. Metamorphic origin. Formed from the weathering of rocks that have undergone transformation due to extreme heat, pressure, or chemical alteration. Organic origin. Materials resulting from the decomposition of plant and animal matter, contributing to soil formation and carbon-rich sediments. Wind and water sources. Aeolian deposits. Wind-derived materials like sand dunes and loess are transported and deposited by air currents, forming distinct geological features in arid and semi-arid regions. Marine deposits. Materials from ocean sources, including coastal sediments and deep-sea oozes, are influenced by wave action, ocean currents, and biological activity, contributing to diverse marine environments. Lacustrine materials. Deposits originating from lake environments, such as clays, silts, and organic matter, accumulate over time, reflecting past climatic conditions and hydrological processes. River and ice sources. Fluvial materials. Sediments transported and deposited by rivers and streams. Glacial deposits. Materials moved by glaciers, including moraines and till. Specialized deposits. Fluvio-glacial. Materials derived from valley glaciers and their meltwater streams. Volcanic deposits. Materials from volcanic sources including ash, lava, and pyroclastic flows. The continuous cycle. Denudational processes work together in an endless cycle, constantly reshaping Earth's surface through weathering, erosion, transportation, and deposition. Rock formation. Weathering, erosion, and transport. Deposition. Understanding these processes helps us comprehend how landscapes form and change over geological time.